Hello everyone, welcome to this channel. If you're new here, my name is Hasan. Let's begin our 16th part of the video series. In this video, I'll be discussing about refraction due to curved surfaces. That is, whenever an object is kept in front of a curved surface, where will be the image formed? And we'll be looking into that, we'll be deriving that formula. Okay, so the straightaway formula is mu2 divided by v minus mu1 divided by u is equal to mu2 minus mu1 divided by r. I'll be explaining each term that is used in this formula and also explain which medium should be taken as mu2 and which medium should be taken as mu1. So whenever tricky questions are asked, I've seen students getting confused that they ask which one should I take as mu1 and which medium should be taken as mu2. So I'll solve that confusion today in this video. So without any further delay, let's jump into the concept and enjoy. So let's get started. So let's understand the concept of refraction in spherical surface. That is, whenever the object is kept in front of the spherical surface, then how will be the image produced, or where will be the image produced, and what will the property of the image that is produced. We'll be looking into this today. So as you can see that this is the object that is kept in front of the spherical surface and is kept in a rarer medium having refractive index mu1, and the spherical surface having refractive index mu2 and is a denser medium. Okay, this much is clear. Now in order to produce image, we know we at least require two rays. So this is the first ray, as you can see it here. Okay, and it goes and refracts. As we know that whenever a ray of light moves from a rarer medium to denser medium, then after refraction it moves towards the normal, isn't it? So as you can see, this θ1 is actually the angle of incidence and this θ2 is actually the angle of refraction here, as this is the normal. The white dotted line is the normal, and as you can see that after refraction this ray has moved towards the normal because the ray is actually entering from the rarer medium to denser medium. I hope this much is clear. Once this much is clear, now we'll be taking into account another ray because we need the intersection point for the image to be produced. Okay, so the second ray, we will take it as the ray moving along the principal axis. So this ray will move and intersect here, therefore we'll get the image at this position. I hope this is clear. Once this is clear, now let's move on. We know all the measurement that we'll be doing is from the pole, and this thing has already been explained while I was explaining the concept of sign convention while teaching the concept of reflection in mirror. Okay, the sign convention. So we'll be applying the same concept here. That is, the measurement is done from the pole, and number two is the direction of incident ray is always taken as positive. So any movement that is going against the incident ray will be taken as negative. Simple as that. So this is very easy. Okay, now before moving, we need to take into account certain assumption. Okay, the assumption that we need to take into account is that the ray is actually paraaxial. Okay, paraaxial. And what is paraaxial? I have already explained in my earlier videos, but I will repeat it again, that paraaxial means whenever a ray of light is almost parallel to the principal axis, then we say that that ray is actually paraaxial. Okay, suppose this is our principal axis, then if the incident ray is moving in this fashion, that is, the angle produced with the principal angle is very, very small, then we say that this kind of ray is actually paraaxial, that is almost parallel to the principal axis. I hope this much is clear. Now if the incident ray is paraaxial, then we can say that the angle produced here is very small. So this is the thing that you need to remember. So all the studies that we are doing in this chapter is actually for paraaxial rays, okay, and thin lenses. I have mentioned this earlier also. Now let's move on. Now let's take a point here as M and draw a perpendicular here on the principal axis. Okay, now if this incident ray is paraaxial, as you can see it here, then this point M will be very, very much closer to the pole, isn't it, if the ray is paraaxial? For simplicity, I have made the figure a little bit big so that I could explain the ray diagram. Okay, if this M is very much closer to the pole, then we can say that this point and this point will almost coincide. Okay, so I hope this is clear. Now let's understand. This θ1 is actually incident angle and this θ2 is actually refraction angle. Now we'll be taking into account some other angles, that is this angle, that is the angle made by the incident ray with respect to the principal axis will be taken as alpha, and we know that this is the normal, the dotted white line, the angle that the normal makes with the principal axis as beta, and the angle that the refracted ray makes with the principal axis as gamma. Okay, so don't worry, things will become very, very clear. Now tan alpha will be, we know tan theta is perpendicular by base. So perpendicular here, suppose this length is taken as h, okay, height. So tan alpha will be h by minus u, because we are going against the incident ray, isn't it, in this direction, because measurement is done from the pole. So u is actually object distance, we need to move in this direction, therefore it is minus u. So tan alpha is h by minus u. We got this from the triangle OMP, okay, simple. So this is our first tan theta. Tan beta can be written as h by r, where r is the radius of curvature. If this is the center of curvature, then the distance from the pole to the center of curvature is actually the radius of curvature. Simple as that. If you just understand the diagram, then things are easy. Tan beta, we got it from triangle MPC. Done. And tan gamma can be written as h by v, isn't it? So again, we got this from the triangle MPI. Done. Now we know that since the rays or the incident ray is paraaxial, we can say that sine theta is equal to tan theta is equal to theta when theta is very, very small. And we know that angle produced here, that is alpha, beta and gamma, will be very small. Why? Because the assumption here is that the rays, incident ray, is paraaxial, isn't it? So we can say that tan alpha can be written as alpha is equal to h by minus u, beta can be written as h by r, and gamma can be written as h by v. Simple as that. Now we will be using Snell's law in order to find out the position of the image produced. Okay, so if we apply Snell's law, we know that Snell's law can be written as mu1 sine of I, here sine I is sine theta 1, is equal to mu2 sine theta 2 is the angle of refraction. So we are actually applying Snell's law. So I'll write it down, Snell's law. Okay, now since the rays are paraaxial, we can say that the angle of incidence will be very small and the angle of refraction will be very small. So we can say that mu1 sine theta 1 can be written as theta 1 and mu2 sine theta 2 can be written as theta 2. Okay, we can say that since theta 1 and theta 2 is equal to very, very small. Why? Because the incident ray is paraaxial. Okay, now if you look into this figure again, okay, there's a concept that you need to understand for a triangle, that if this is a triangle, okay, then we know that the exterior angle is equal to the sum of the opposite interior angle. I hope this is clear. So if this angle is A and this angle is B and this angle is C, we know that angle A plus angle B should be equal to angle C. That is, this is the property of triangle. We know this. We have learned this thing in class 9-10. Okay, that the sum of the opposite interior angle is equal to the exterior angle. Okay, so angle A plus angle B will be angle C. So we'll be applying this technique here. Now for triangle MOC, okay, you can look into the figure. For triangle MOC, we can say that alpha plus beta, these are the two interior angles, should be equal to theta 1. This is the exterior angle for triangle MOC. Clear? And for triangle MCI, we can say that angle gamma plus angle theta 2 should be equal to angle beta. Look into the figure and this will be clear. We are applying this concept. Okay, so from here we will find out the value of theta 2. Okay, and we will be using that in Snell's law. So theta 2 can be written as beta minus gamma. Now we'll put the value here and here. So mu1 theta 1 is actually alpha plus beta, and mu2 theta 2 is actually beta minus gamma. Now mu1, now we'll be putting the value of alpha, beta and gamma from this formula as we have found out. Okay, this is alpha, this is beta and this is gamma. Simple as that. So alpha will be h by minus u, beta will be h by r is equal to mu2, beta is h by r minus gamma is h by v. Okay, now since we have put this value, we are almost at the end of our derivation. Now from here we can find out that if we arrange this thing, then this will turn out to be mu2 by v minus mu1 by u should be equal to mu2 minus mu1 divided by r. Okay, this is the formula that you will get if you just arrange this thing. Okay, so this is a very important formula and you need to remember this. This is important. Okay, so from here you can find out the location of V very easily. Okay, so in your question mostly they will give you the object distance, they will give you the radius of curvature, they will give you the refractive index of the rarer and denser medium, and you can easily find out the value of V. Okay, you need to put the sign convention for each value. Okay, that is for U and R, you need to put the sign convention. Otherwise, you'll get a wrong answer. Okay, so this formula is very important. You need to remember this again. So let me write it down. Mu2 by V minus mu1 by U should be equal to mu2 minus mu1 divided by R, where R is the radius of curvature of the spherical surface. Okay, now the most important thing for this formula that you need to understand is which medium should be taken as mu2 and which medium should be taken as mu1. And I've seen students getting confused here. Okay, so I'll keep a star sign here and let me explain you which one should be taken as mu2 and which one should be taken as mu1. Mu2 is the refractive index of the medium where the rays are entering. Okay, so the medium in which the rays are actually entering should be taken as mu2. Never ever think that mu2 is the refractive index of the medium where the image is produced. Okay, if you take it in this way, you'll get confused. And mu1 is the refractive index of the medium where the rays are coming from. Okay, so very important. So the medium from where the rays are coming is taken as mu1, and the medium in which the rays are entering should be taken as mu2. Okay, simple as that. Just remember this, apply this, and you can solve this kind of question very easily. So this is the conceptual part and the formula that you need to remember. So if you understand the formula and the concept that I have talked about so far, you can solve any question that is asked from this part. Okay, so let's dive into some of the numerical problem in order to solidify this concept. Okay, so let's move on. Okay, now let's look into this problem, and if you know the formula, you can easily solve this kind of question. So this is very simple. Let's look how to solve this question. It says find the position and nature of image, and 4 options are given: 60 centimeter real, 60 centimeter virtual, 90 centimeter real, 90 centimeter virtual, and it said that the object is kept 30 centimeter in front of the spherical surface, and the radius of curvature of the spherical surface is 10 centimeter as given. And it says that the spherical surface is made up of glass having refractive index 1.5, and this is air having refractive index 1, as we know that refractive index of air is 1. Okay, what will be the position and the nature of image? Just apply the formula and you can easily find it. Okay, so let's write out the formula, that is mu2 by V minus mu1 by U should be equal to mu2 minus mu1 divided by R. Now I told you that U, R, these values should be put with proper sign. So if you look into this figure, then we know that U here is actually minus 30 centimeter and R will be plus 10 centimeter, because the ray will move in this direction. Therefore this direction should be taken as positive and the opposite direction should be taken as negative, and this is the pole and the measurement should be done from the pole. I hope this much is clear. Now just put the value and you'll get the result. Now I'll be taking mu2 as the refractive index of the glass because the rays are entering into the glass medium, and we know that the medium in which the rays are entering should be taken as the second medium, and the medium in which the rays are coming from should be taken as the first medium. Therefore since the rays are entering into the glass medium, therefore we say that the glass is actually the second medium, and we treat mu g as mu2. Okay, so we can say that mu2 is that of refractive index of glass, therefore 1.5 divided by V we need to find out, minus mu1 is the refractive index of air, which is 1, and U is the object distance, which will be minus 30, is equal to mu2, again 1.5 minus 1 divided by radius of curvature is given to be 10 centimeter. Now if you solve this, then we can easily find the value. So this will become 1 by 30 is equal to 1.5 minus 1 is 0.5 by 10, which we can write down as 5 by 100, and again we can say that this is 1 by 20. Okay, so now we can write out that 1.5 divided by V is equal to 1 by 20 minus 1 by 30. If we just do the LCM, we'll get 30 and 20 LCM to be 60, and then this will be 3 minus 2 as 1, or 1 by 60. Okay, now V, if we cross multiply, we will get V is equal to 1.5 multiplied by 60. Now if you just multiply this, then we'll get 90 centimeter. I hope the concept is clear. So the value of V is actually plus 90 centimeter. Now here is the thing. Since the value of V is equal to plus 90 centimeter, we can directly say that the option C will be the correct answer, that is 90 centimeter real. Now plus 90 centimeter suggests that the image is formed somewhat here, okay? That is, we know the measurement is done from the pole, so the 90 centimeter is actually from the pole and the direction is in this direction, isn't it? Because we have seen here that this direction is taken as positive, therefore we should go 90 centimeter in this direction to get positive 90. If our answer was minus 90, then we need to go from pole this direction 90 centimeter, okay? So we can say that the image is actually real. Always remember that for lengths, whenever the object and the image are produced on the opposite side, then we say that the image is actually real. And whenever the object and the image are produced on the same side, then we say that the image is virtual. Okay, now since we have got the value, now we can draw the ray diagram. It's easy for us to draw. Now let's see. We require two rays in order to get the location of the image. So this is our first ray, and suppose this is the normal. Okay, therefore we know that the ray after refraction will bend towards the normal because light is entering from the rarer medium to denser medium. Okay, and this is our second ray that is along the principal axis, and we can see that the image that is produced is due to actual intersection of the rays. Therefore we can say that the image produced is real. But the easiest way of finding out is that even if we don't draw the ray diagram, we can directly say since the object and the image are produced on the opposite side, then we can say that the image is actually real. Okay, just go through my previous video, that is image formation by lens. You'll see that the virtual images are produced on the same side as that of the object. Okay, so this is all for this question. I hope the concept is clear. Now let's move on to our second concept in order to solidify this concept more. So let's move on. Okay, now let's look into this problem. Find the position and nature of image, and you see the object is kept 20 centimeter in front of the spherical surface, and the radius of curvature of the spherical surface is given to be 10 centimeter. Okay, and the refractive index of the spherical surface, and the spherical surface is actually made up of glass, and it says the refractive index is 3.2 or 1.5, and the refractive index of this medium is water, that is 4/3. Okay, this is water medium. Now you need to find out the position and the nature of image. So let's see, we need to just use the formula and things will be easy. So this is the formula that we need to use. Mu2 by V minus mu1 by u is equal to mu2 minus mu1 divided by r. Now I have already solved this because see, this is similar to the first problem, so you can easily solve this. You just need to apply this formula. So just put the value of mu2 and mu1 and the value of u and r, and you can easily get the answer. Now which one will be mu2? Now the object is kept here, and therefore the incident ray will move in this direction. Okay, so this direction will be taken as positive, and since the rays are coming from the water medium, therefore the water medium will be treated as the first medium, and since the ray is entering into the glass medium, therefore the glass medium will be treated as the second medium. Therefore mu g will be treated as mu2 and mu w will be treated as mu1. So mu2, that is mu of glass, is 3/2 as you can see, and mu1 is that of water, 4/3, and we have taken u as minus 20 according to our sign convention. Then we have just put the value of mu2 and mu1, that is 3/2 and 4/3 respectively, and the value of radius of curvature is 10 centimeter, which will be positive. Okay, once you start solving this, we will finally get that V is equal to minus 30. This is what I need to show you. Okay, so V is equal to minus 30. In our earlier case, we got V is equal to plus 90 centimeter, isn't it? And we said that the image that was produced is real image. Here we got V is equal to minus 30 centimeter, which suggests that the image that is produced is actually virtual. Now minus means in which direction? So this is positive direction, and we know this is negative direction. So the calculation or the measurement is done from the pole. We know this is the pole, therefore minus 30 centimeter actually means we need to move in this direction 30 centimeter. So the image is somewhat formed here, okay, that is 30 centimeter in the opposite direction to that of the incident ray. I hope this much is clear. Now since the object and the image are on the same side, therefore we can say that the image that is produced is virtual. Therefore the answer will be 30 centimeter virtual, option B. Okay, in our earlier case we saw that the object and the image was on the opposite side, therefore the image was real. Now how to explain this by ray diagram? So let us see that. We know in order to get the image we require two rays. So this is our first ray, okay, and suppose this is our normal. Okay, Therefore, now as you can see, the ray is entering from the water medium to the glass medium, and the glass medium is optically denser than the water medium. Therefore, after refraction, the ray will bend towards the normal, as you can see, but the bending will not be very much drastic as we have seen in our earlier case. Here the bending will be very much less. Therefore, the ray will go in this direction, and the second ray is along the principal axis. Therefore, you can see that the first ray and the second ray are diverging ray. Therefore, they will never meet there. Therefore, they will meet in this position. If we extend both rays backward, we will get this position as the meeting position. Therefore, we can see that the intersection is actually false intersection. Therefore, the image that is produced due to that kind of intersection is actually virtual image. Okay, so I hope the concept is clear. So when will be the image real and when will be the image virtual? So this is all for this concept. Now let's move on to our next question. Okay, now let's look into this problem. I'm just giving you this problem in order to make the concept of mu1 and mu2 clear. That is, which one to take as mu1 and which one to take as mu2, and the sign convention of R and U, and when is the V real and when is the V virtual. I need to explain this thing, so I'm just repeating these kind of sums to make things clear for you. Okay, so let's see. A dust particle O is inside a sphere of refractive index 4/3 as shown. Where does it appear to an observer outside the sphere? Okay, so this is the dust particle, as you can see, O. It is at 10 centimeter from this point. Okay, and it says the radius of the sphere is 15 centimeter. Simple. This is our observer. It's given. Now the observer can be anywhere, either this side or the observer can be this side. Okay, we'll be looking into that both. So first of all, let's analyze the observer is here. Okay, and the observer is in air medium. So the refractive index of air is 1, and the refractive index of this sphere is actually 4/3, that is of water. So let's see where will be the image formed and what will be the nature of the image. Okay, so we'll be using the formula mu2/v minus mu1/u is equal to mu2 minus mu1 divided by r. Okay, so let's understand. Since the object is kept here, so the ray will go from here and enter into this medium. We know that the medium from which the ray is coming is actually the first medium, and the medium in which the ray is entering is actually the second medium. We can see that the ray is coming from this medium. Therefore, you can say that this medium is actually the first medium, and since the ray is entering into this medium, therefore this medium will be considered as the second medium. So we got mu2 and mu1. Okay, so we can say mu2 is that of air, so we put 1, and mu1 is that of this, therefore we put 4/3 here, and u is the object distance from the pole, because the measurement is always done from the pole. Now if this is the curved surface where the refraction is taking place, we can say that this is the center, then this will be the pole, isn't it? So we'll be measuring it from this point towards this direction, which is actually opposite to the direction of incident ray. Our incident ray is in this direction, therefore this is taken as positive, and this direction will be taken as negative. Simple as that. Now let's see. Once this is clear, u will be minus 10 because we need to move in this direction. So u is minus 10. We got the value of mu2 as 1, mu1 as 4/3, and r, again the radius is minus 15 because the direction is opposite to the direction of incident ray. See, if this is the pole, then we need to measure it from here to here. Okay, that is minus 15 centimeter. Therefore, we got the radius of curvature to be minus 15 centimeter. Now, if you solve this, we will get v is equal to minus 9 centimeter. I haven't solved this because it's easy. You can do it. Okay, I just need to explain these concepts. So v is minus 9 centimeter. So this means that the image is actually virtual in nature. Okay, so the image will be formed somewhere here, minus 9. So if you move it in this direction, then it will be minus 9 centimeter from the pole. Okay, as you can see that the object and the image are in the same side, therefore it will be virtual. Now if you want to draw the ray diagram, let me rub this all and draw the ray diagram for you. So if this is the normal, okay, this is the normal, and this is the incident ray. Okay, now the ray is entering from denser medium to rarer medium. Therefore, after refraction, it will bend away from the normal. Therefore, it will bend in this way. And the second ray, because we require two ray for intersection, second ray will be along the principal axis. And we can see that they are diverging ray. Therefore, they will not meet. So what we will do, we will extend this ray backward and we will get the image somewhere here. Therefore, you can see that the image is formed due to false intersection. Therefore, the image is virtual. I hope this is clear. Now let's move on to our second condition. If our observer was here, okay, in this side, then what will be our answer? So let's look into that. Now again, mu2, if this is the object, then the ray will go from this medium and enter into this medium, isn't it? So we can say that this medium will be mu1 and this medium will be mu2. Okay, so mu2 is actually that of air and mu1 is 4/3 that of water. Okay, now u is minus 20. How? See, the radius is minus 15. Okay, because now this is the pole and the measurement will be done from the pole. Now this is the direction of incident ray, so this will be taken as positive and the opposite direction will be taken as negative, isn't it? So we need to go in this direction to find the radius of curvature. Therefore you got radius of curvature as minus 15 centimeter and the object is 10 centimeter from this side. Therefore this is again 5 centimeter. Total is 15 radius. Okay, so the object is actually at a distance of minus 20 centimeter. I hope this is clear. So we've got minus 20 centimeter as u and radius of curvature as minus 15. Just put the value and we will get v is equal to minus 22.5 centimeter. Minus sign suggests that again the image that is produced is virtual. Okay, now minus means in which direction? In this direction. Okay, so the image is produced somewhere here because this is 20, so it should cross 20 and it will be minus 22.5 somewhere here. Okay, as you can see in this direction. So you can see that the object and the image are on the same side, therefore it is virtual. Now let's understand the ray diagram. Let's draw that. Okay, now if this is the normal, okay, then this is the object and the incident ray will go and hit here. And we know the incident ray is going from denser medium to rarer medium. Therefore, after refraction, the ray will bend away from the normal. Okay, this is the first ray, and the second ray is parallel to principal axis or along the principal axis. These two are diverging rays, therefore they will never meet. Therefore, the only way that they can meet is by virtual intersection. So as we can extend this, okay, backward, we will see that this is the intersection point. And this point is the point where the image will be formed, that is at minus 22 centimeter. Therefore, we can say that since the image is formed due to false intersection, therefore the image is actually virtual in nature. I hope this concept is clear. Yeah, this is all about the concept. So we can wrap up the video here. So if you enjoyed this video, then please give it a thumbs up. And if you haven't subscribed to this channel, then please consider doing so. Till next time, enjoy your studies and build your concept. And I will catch you all in my next video. Bye-bye.